Okay, so good day everyone. So today I'm going to be solving a Solidworks problem, which is a sheet metal problem. This problem you have seen here. So we have the sketch and everything. The first thing I'm going to do is just look at the problem a little bit to examine how I want to model it. So from the way I'm seeing it, the best way to model it is at this front plane here with the curve. And then since the sheet metal, we're not going to use a close profile. So let me just get into it. So to start with this, since I'm starting with this sketch here on the front plane, just going to, yeah, I'm going to increase going to start it here. So going to start with this sketch here on the front plane. And I'm going to make this my origin, the center of this giant arc here. Center point arc. Center point arc. Within the trouble time frame. Okay, it's just so now if you notice there's actually another arc here that also has a radius of 30 milliliters. So I'm going to use a 3-point arc for this. Just give it and just take it, just let it curve in a way. Then I'm going to draw this line here. Comes in. I don't think the line isn't straight yet, but that's not an issue. I'm going to draw a line here from going to make sure this one is straight, make it a construction line. Now I'm going to click on these two lines and just make this line here parallel because this line wasn't straight before, so I'm just straightening it up. Then this needs to be continuous. So for that, we're going to use the tangency relation. And that automatically just makes it continuous. And yep. So yeah, set the radius of this arc here to 30. And the length of this line here to 33.34. And what's next again? I think the distance between these two places has to be 17.5. And then distance from here to here. Okay, it's already 70. Wait. So instead of me drawing this arc and this line again on this side, I'm just going to mirror it. Select entity, select entity, select the line I want to mirror about, which is this line. And okay. And I'm just going to drag this endpoint here to meet it here, and automatically it becomes coincident. But in case you can't do that, you can just click on this line, click on this, sorry, click on the two endpoints, that is this one and this one, and then just select the coincident relation, and it still does the same thing. So since this is a sheet metal, I'm just going to go to sheet metal tab and click on base flange slash tab from here. I'm going to set this to be on a mid plane. And okay, I think I'm done with, okay, so if you notice the distance, the extrusion is 45 milliliters. So 45, and then the thickness is, this is T1, is 2 milliliters. You see it from here. This place that tells us the thickness is 2 milliliters. So just draw a single line and yeah. So that's how we usually get all these curved surfaces in sheet metal. The next bit is going to be this edge flanges. So this edge flanges here, that's going to be the next bit. And yep. So I'm going to click on edge flange and select, should I? Okay, nope. Let me, okay, edge flange, select this outer side here. Yep. Select this side. Yep. Mm, select this side and select this side. Okay. So for distance, if you notice here, they told us that the length of the flange is 18 milliliters is given here. So that's what we're going to use, 18 milliliters. And there's another thing. We know that it is, you know what, let me just show you what happens if I go through like this. Also, you want to use this outer virtual sharp for your dimensioning so that the whole distance of the flange is going to be 18 milliliters. I'll show you what I mean just now. So let's first verify the 18 millimeter dimension that we want. I'm going to, okay, let me use this one. Click on this and click on this outer face here. And you can see normal distance 18 milliliters. That is the most important part. Normal distance 18 milliliters. But there are two issues. The first of which is that the distance from this place to this other outer face here is 45 milliliters. But in the drawing, it's meant to be 53 milliliters. Look at the 53 here. And also, this bend is going to be happening outside of your original 45 millimeter that's been drawn. So edit feature, and I'm going to set it to be outside, bend outside completely. Click on OK. But there'll still be another issue that when you measure it, it's still going to be above 53 milliliters. And why that is happening is because of the radius of this bend. So anytime you want to reduce the distance between these two faces, you are going to need to reduce the radius of the bend. And normally I would have loved to, go around and start manipulating values, but I already know that if I make this bend 2 milliliters, okay, okay, then the new distance here is going to be 53 milliliters. Measure. Yep, now it is 53 milliliters, just like we're looking for. So the next part is going to be chamfer. I'm just going to I'm going to chamfer this cut instead of using cut extrude or something, just chamfer. Go to features, under fillet, click chamfer, and just select 1, 2, 3, 4, 5, 6, 7, 8. Yep, so everything is chamfered now. The next bit is going to be the cuts. So instead of, I'm just going to make all these cuts at once. Every single cut here, I'm just going to make everything at once. And to do that, I'm going to need to make this place straight. Now there are two ways. One if of which is when you're using a sheet metal, even then anything that is curved, bent, you can always just right click on a straight face and click flatten, and it automatically flatten it out for you. But you only want to do this when you're ready to like draw and you're at the end of everything. You don't want to do it when you still want to make a cut. So when you still want to make a cut, I need everything to be flat. We use the feature called unfold in sheet metal. That is this one here. So you select the unfold feature, you select the face that is going to be fixed first. Then you're going to select all the faces, all the bends. This, for example, now is a bend. This one here. This one here is another bend. And this one here is another bend, another bend. This place here too is another bend. this place too is under bend. This place is under bend. I didn't select this face here because by the time you bend it, it's going to be straight. By the time all these ones are bent, you see it that it's straight. So I click on OK, and I've automatically gotten that straight profile we're looking for. Okay, control and control 3. Right. So now I'm going to sketch on this one case here. The first thing I'm going to do, I'm going to draw my middle lines, center lines, and click on this one, make it a for construction, draw another center line again, make it for construction. And I'm sorry if I've been using shortcuts, but for your line tools, you can always carry it from here. And so I'm going to start with this place here. So I'm going to draw, so I'm going to select my line tool, draw that is. Then I have a neat trick for this particular case. Your line tool can also create an arc. All you have to do is, instead of drawing a line, just simply hover back to the point that you last stopped at and drag your line tool, and it automatically create an arc. So that's what I'm going to be doing. Draw, hover, draw an arc, draw, hover, draw an arc, draw, over. Okay, that one went slightly wrong. Draw okay over now, and okay. Hmm. Solidworks applied some relations for me. So in the meantime, all the center of the arcs should be on these middle lines. That will automatically set a symmetric relation for us. I'm going to show you now. I'm going to select the center of this arc, select the center of this arc, and I'm going to select this line here in the middle and click on E. So, okay, I'm going to select this, click on point. Sorry, I'm going to select, okay, I need to go back to sketch. I'm going to select this point, select the line, and select coincidence. For this one, to select the point, select the line, select coincidence. Now, what this does is that you know what? Okay, I know what to do. Just going to select these two arcs too and set them to be equal. And then now everything should be symmetric. Yes. So once I change the distance of one to reflect in the other one, so I'm going to repeat the same process for this center line and the center point and that line, make it coincident. Go here to click on the center line, hold down your control button, click on this line in the middle, click on coincident. Yep, and select these two arcs to be equal to each other. And that should automatically set the symmetric joint for everything. So if you look here, the radius of this arc here is 3.5. The radius of this arc is 3.5, so apply it 3.5. Apply it here to be 6 millimeters. What's next again? 60. Okay. The distance between these two centers is 60. I'm seeing on that thing that is a bit wrong. I'll correct it. And then the distance between these two centers is 25. So what I said is wrong is that if you notice, it is still not fully defined. These 2 points are meant to be, it's meant to be 11 millimeters from this center line to this place, 11 millimeters from the other point to this place. And 11 millimeters from this center point to the center line, 11 millimeters from this center point to the center line. So 30 millimeters for like these ones that are vertical. So one way is that I can actually add the dimension. If we were to add the dimension now and put 11 milliliters from this place, then this side is already fully defined. But there are some things that I don't like adding dimensions for when like centers and everything. Because imagine if like let me show you something. Imagine if I put the dimension of 11 here and then I come back and change this to 30, then it suddenly becomes unequal because I coded this dimension here. But if I were to use a relation instead, let me take this back to choose 5. If I were to use a relation instead, for example, I'm just going to undo a bit. Good. So if I were to use a relation instead, which is select this point, select this point, select the line in the middle, set everything to be symmetric. Now, without using a dimension, I've automatically set the distance from this one to be 11. Just told you that, you know what, these two points should always be sharing an equidistant distance to this center line. So now if I were to change it to 30, then it gets distributed equally among these 2 points. So like that's just the reason why I prefer using relations for some things instead of dimensions. So I'm going to select this point here, hold down Control button, select this other point, select the line in the middle last, and set everything to be symmetric. And that does it for this place here. For this one, I'm going to draw a line. Don't make it in the midpoint, please. Just draw a line. Make this a construction line. Then set a distance of 16.5. So distance of so select distances, select this line here and 16.5. So draw a circle. So I have a shortcut of drawing circles, which is C. But let's draw a circle. Draw a circle. Let's set the distance of the circle to the outer edge to be 7 milliliters. 7 milliliters. And set the diameter of the circle to be what is okay, diameter of the circle is 7 milliliters. Just drop in 7 there, click on enter, and yep, that's it. So instead of doing it on this side again, just use your mirror entities, mirror everything about this line, select what you want to mirror, which is this circle, click on OK. And for this, there's a word for it here. The word for it is slot. For this slot, I'm going to use my line to carry it. Then use the needle trick to just draw the axe, which is draw the line over above the line, carry it. Then as usual, just make sure the 2 points are coincident with this line. Like this, and select the line in the middle, make it symmetric. Then since there's no breakage in this line, I can just select the line instead of selecting the 2 points. Selecting the line is easier. Select 22 milliliters. What's next? And the radius of this to be 5. And that does it. So all we have to do is mirror all these cuts to the other side. Mirror entities 1, 2, 3, 4, 5, 6. and select the line I want to know everything about, which is the line at the center here. And yeah, that does it. That is everything I want to do. So select sheet metal, select extruded cut. And automatically when you select extruded cut, SolidWorks will select all the close profiles for you to cut. So like this now, if I click on, let me set it true. All. If I click on OK, SolidWorks has already made all the cuts for me. But I personally, I just like selecting all the profiles myself. So I'm going to go back to click on um, selected contours and select all the regions myself. Okay, okay, great. Uh-huh. So now everything is still flat. So we're going to need to, since we folded before, since we unfolded it before, we can now use the fold feature to just, should I say refold or defold or well, what matters is that you understand what I'm saying though. So we are going to select all the bends that we folded before. This one, and click on OK, and automatically it takes the original shape that it is meant to take. Let me 7 quick. So automatically it takes the shape that we're looking for, and this is everything. So thank you for listening. And yeah, you can also choose to still flatten it out. Click on it, click on flatten. And yep, that is the how it is looks when it is flattened. So please, if you have any question, you can just ask it in the comments and I'll reply. Um, have a good day and good luck.